Welcome to this video. In this video, we are going to discuss an important class of groups, that is nilpotent groups. In the particular lecture, we are going to discuss definition and some of its example, and we'll see what is the relation between nilpotent groups, abelian groups, and solvable groups. So let us start the discussion by a definition of nilpotent groups. Definition, and this definition defines nilpotent groups. Definition: nilpotent groups. So G let G be a group. We define the ascending central series, that means series containing the central series, that is Z1 G contained in Z2 G contained in Z3 G contained in, and so on, of G as follows, that is following some conditions. The first condition is that Z not G, which is actually not in this ascending series, Z not G is the subgroup identity containing identity only. The second one says in the series, the first Z1 G or the first element of this series represent the center of G. So Z1 G is the center of center ZG of G. Okay, so this Z1 G is nothing but center of G, or you can say Z1 ZG. Then the third requirement is that Z2 G is unique subgroup of G with Z1 G contained in Z2 G and contained in Z2 C, and the vector group Z2 G over Z1 G is equal to center of G upon Z1 G. G upon Z1 G. Okay, so this must have for every kind of vector or every kind of pair. Then we can define, similarly you can say Z3 is a unique subgroup of G with Z2 G contained in Z3 G, and Z3 by Z2 is equal to center of G upon Z2 G. Okay, so let us define in general for any ZIG. Okay, similarly ZIG is unique subgroup of G with Zi minus 1 contained in ZIG, and the vector group ZIG over Z I minus 1 G is equal to center of G over Z I minus 1 G. So the each part of this ascending series follows this kind of rule. Now for a specific case, we will call this due to this ascending series, we will call G as a nilpotent group. Okay, so let me write that. So I'm saying if there exists there exists a positive integer n such that the nth center is equal to G itself. Okay, then G is said to be nilpotent nilpotent groups nilpotent group. Okay, so this is an important class of groups in which we are discussing nilpotent groups. Okay, now we have already studied soluble groups and abelian groups, and in the discussion of soluble groups we have discussed that each abelian group is soluble. Okay, now we are having a question in which if we have any nilpotent group, then is it soluble? The answer is yes. Okay, so we have that every nilpotent group is soluble. Okay, अब soluble के लिए क्या होता है हमारे पास? We can consider the four conditions. The first one is we must have a series G that contains something that contain and so on. Then we have the second condition is that each ni is normal in n I minus 1, and then in the third part we have ni minus 1 over ni is abelian, and then the fourth one was that this n naught must be the identity. Okay, तो ये हम कैसे प्रूफ कर सकते हैं? लेट मी राइट दैट. सो लेट G be a nilpotent group, then we must have a positive integer n such that z and g is equals to G, and having an ascending central series as we must have z1g contained in z2g contained in and so on. We have z and g, and that is equals to G. So our series terminates here. Now you can see, so to show G is soluble, let us suppose this is our series 1. Let us rewrite the series 1 as, we can write this as G that is equals to Z and G contains Z n minus 1 G contains and so on content Z2G containing Z1G. So we can consider this. Now we need to show that this Z1G is the center of G, and that has to be equal to identity. Okay, this is the last one. So we will try to prove that this is the identity one. Okay, but before that, since Z I minus 1 is this each Z I minus 1, this one is center of Z2G. Okay, Z I minus 1 of G contained in contained in ZIG, and we have that ZIG vector group with Zi minus 1 G is the center of some group, that is G upon Zi minus 1 G. We know that each center of any group always in abelian group, so we have that this kind of vector group is abelian. And moreover, if we are talking about vector group, that means this center is normal subgroup in ZIG. Okay, since this is happening, so, or we can say therefore this is Zi minus G, because this is representing center, okay, is normal in ZIG, and क्योंकि ये सेंटर है और ये सेंटर के इक्वल है, दैट्स व्हाई वी आर राइटिंग ZI G of Zi minus G is abelian. And also we have that Z naught G, that is equals to identity, and that is nothing but center of G, and we call this as Z1 G. So we have, you can say also we have this, therefore, so it is now equal to identity. Okay, hence G is solvable. Okay, so every nilpotent group is solvable